In the vast tapestry of nature, intricate patterns emerge through the elegant language of mathematics.
From the graceful, symmetrical petals of a flower, mathematics quietly orchestrates the symphony of life around us. But these patterns are more than just aesthetically pleasing. They are the result of intricate mathematical principles at work. Prepare to be amazed as we journey through forest and river, revealing the hidden mathematical symmetries. This is Mathematics in Nature, a testament to the beauty and brilliance of the mathematical universe that surrounds us. Handa ka na ba?
Take for instance, the delicate petals of a flower. Their arrangement follows the Fibonacci sequence.
This sequence dictates that each number is the sum of the two preceding ones, resulting in a mesmerizing spiral pattern, a mathematical marvel found abundantly in nature.
If you count the number of petals on certain flowers, you'll often find that the count matches the number in the Fibonacci sequence. For example, some flowers have 3 petals, others have 5, 8, 13, or 21, and the pattern goes on. Spiderweb spun with precision embodies mathematical symmetry. Each thread meticulously woven to create a masterpiece of natural engineering. The radial symmetry of the web ensures strength and efficiency, demonstrating nature's adherence to mathematical principles.
In the dazzling light of the forest, we witness the phenomenon of tessellation.
A repeating pattern of shapes fitting together without any gaps or overlaps. This mathematical concept is evident in the mosaic-like arrangement of leaves on the forest floor, forming a seamless mosaic of shapes and shadows.
Even the grass, with its seemingly random growth, exhibits mathematical precision. The arrangement of blades follows geometric patterns, optimizing sunlight, capture, and airflow to promote healthy growth.
Amidst a canopy of leaves, we discover another intriguing pattern, the arrangement of the leaves in a branch.
Known as pilotaxis, this pattern follows a mathematical sequence that optimizes sunlight exposure and nutrient distribution. The spiral arrangement of leaves maximizes efficiency, allowing each leaf to receive adequate sunlight without shading others.
As a stone is gently tossed into a river, it creates ripples that propagate outward perfect circles. These concentric circles demonstrate the principles of geometry and wave propagation, reminding us of the harmony between mathematics and motion. The spiral arrangement of leaves maximizes efficiency, allowing each leaf to receive adequate sunlight without shading others.
Even the rhythmic dance of waves follows a mathematical sequence and pattern.
From the regularity of a river current to the chaotic beauty of breaking waves, mathematics provides a framework for understanding the complex dynamics of flowing water.
In the heart of the forest, trees branch out in fractal patterns, repeating its self-similar shapes and different scales.
Nature's fractals, a mesmerizing display of mathematical recursion. These intricate patterns reveal the underlying unity and complexity of a natural world, echoing the recursive structures found in mathematics.
Consider the humble seashell, a timeless symbol of natural beauty. Its elegant spiral form, such as that of the Nautilus shell, follows the graceful curves of the Fibonacci sequence. This sequence, where each number is the sum of the two preceding ones, governs the arrangement of spirals in the shell, resulting in a captivating pattern that appears throughout the natural world. Venture into the bustling world of a honeybee colony, and you'll encounter another marvel of mathematical precision, the hexagonal honeycomb. The bees meticulously construct these hexagonal cells not by chance but by instinct. Why hexagons? Because they provide the most efficient use of space, minimizing the amount of wax needed while maximizing storage capacity. It is a prime example of nature's economy of design. Amidst the sea of golden petals, the sunflower stands as a beacon of mathematical perfection. The arrangement of its seeds follows the golden spiral, a logarithmic spiral that expounds outward while maintaining a constant angle. This divine proportion, known as the golden ratio, is found throughout nature, from the spirals of galaxies to the curling of ocean waves. As the heavens unleash their fury, the jagged tendrils of lightning reveal the fractal nature of nature's wrath. Fractals, geometric shapes that repeat at different scales, are ubiquitous in the natural world. From the branching veins of a leaf to the convoluted coastline of a rugged shoreline. In the chaotic beauty of a thunderstorm, we witness the raw power of mathematics at play.
Remarkably, this sequence appears in the structures of hurricanes, with their characteristic spiral arrangement of clouds and winds. The Fibonacci spiral, derived from the sequence, can be seen in the spiraling bands of clouds and winds that encircle the eye of a hurricane. The Fibonacci sequence is a fundamental pattern found throughout nature, from the arrangement of petals in flowers to the spiral shells of nails. Hurricanes are no exception. Scientists believe that the Fibonacci sequence influenced the development and structure of hurricanes, contributing to their efficiency in energy distribution and movement.
As the sun sets on a journey, we are reminded of the profound connection between mathematics and the natural world. From the smallest atom to the grandest cosmos, mathematics serves as the language through which nature speaks, a language of beauty, order, and infinite possibilities. For in the study of mathematics lies the key to unlocking the secrets of the universe.